Hi everyone, my name is Mark and I'm a former teacher and former tutor with Tutor Chicago, and I'm here to provide you with some tips on helping students understand fractions. There are a lot of resources that show the steps of various operations with fractions, and you should check out the links that I provide you with at the end of my presentation. Instead of teaching you those things though, I'm going to provide you with examples, explanations, strategies, and ways of presenting fractions for you to use with your students in your sessions. This will hopefully help them better understand the meaning of fractions to assist them with the operations that you are teaching. So, let's get started. Recognizing and naming fractions. At the most basic level, a fraction is just part of a whole. The denominator is the unit of measure, or what you are using to measure that whole, and the numerator is how many of that unit of measure there are. So with the fraction 5/6, students need to understand this fraction means that they are measuring in 6 and that there are 5 of those 6. The best way to convey that the denominator is their measuring device is by saying there are 5 1/6. I think using this language with every fraction that you encounter right now is important, and as students get older they can use the shortcut, which is just 5/6, but I wouldn't start that until years down the line. Another important concept is that the larger the denominator, the smaller the unit of measure. And you can show that by cutting the same size object into more and more pieces. Make sure that they know fifths are smaller than halves. And also, if you want to see how fractions failed in the real world, you can click the link right here. A concept that would be used for the rest of the students' math careers is that as a fraction, the number 1 can be written with any number you want except for 0. It is critical that students know that if you have 3/3, we say that as there are 3 1/3, which is just one whole. Food is the most common way to explain fractions in the real world, but it doesn't always have to be pizza. You can make it healthier by throwing in apple or orange slices, or TikTok is big with kids right now. So if a video has 1 million views but only 25,000 comments, then those people who commented on the video are just a fraction of the total viewers. Ordering and comparing basic fractions. Students need to know that they can only directly compare fractions to one another if they have the same unit of measure or the same number of pieces. Also, students should understand each fraction individually before trying to compare them to another fraction. Important questions for students to ask themselves are listed here, and I'll put them into practice with these examples. First, it never hurts to draw a picture. Not only can drawing a picture help them answer the comparison question itself, it can also help solidify the idea that fractions are parts of wholes and continues to hammer home the roles that the numerator and the denominator play. With 3 1/4 versus 1 1/4, the unit of measure, aka the size of these pieces, is the same. And if the size of the pieces are the same, then you can determine which is larger or smaller by looking at the number of pieces in each. 3 on the left versus 1 on the right. For 2 1/3 versus 2 1/5, the number of pieces is the same, not the size of the pieces. If you have 2 pieces on the left and you have 2 pieces on the right, then you can determine which is larger or smaller by looking at the size of them. In this instance, thirds are larger than fifths, so that we know that 2 1/3 is larger than 2 1/5. For 9 1/10 versus 5 1/8, since neither the number of pieces nor the unit of measure is the same, you cannot make a direct comparison that you are 100% certain about without first finding a common denominator. Now, the intention behind this question, though, is not to have students find a common denominator. Instead, the goal is to have students compare these fractions to what we call nice numbers and then make an inference. So the number 1 is a nice number, and since 9 1/10 has a denominator of 10, we will disguise the number 1 as 10/10, or 10/10. The number 1/2 is also a nice number, and since 5 1/8 has a denominator of 8, we will disguise the number 1/2 as 4 1/8. We know that 9 1/10 is just less than 10 1/10, and we have 5 1/8 is just larger than 4 1/8. And since the first one is close to 1 and the second one is close to 1/2, then we can infer that 9/110 is larger than 5/1/8. Okay, equivalent fractions. Before students can add, subtract, multiply, or divide fractions, they need to know how to simplify or reduce fractions down and scale fractions up. The concept that is used in both of these instances is that the number 1 can be written as a fraction using any number divided by itself. Without truly understanding that, students will never fully understand reducing or scaling fractions. For 2/1/6, when you rewrite the numerator and the denominator as their prime factorization, you will get to a point of 1/1/3 times 2/1/2. When students say this fraction as 2/1/2, they can easily picture in their head 2 halves making 1 whole. And 1/1/3 times 1 whole is just 1/1/3. You never want to use the word cancel in these instances. We never want kids to forget that 2/1/2 is just a whole, or one number divided by itself is 1. So you should say that these divide to be 1, not cancel. When scaling up fractions, you are doing the opposite of reducing. You choose what to scale up by based on the individual problem. So to make the best decision, you usually need to look at the denominators at all the other fractions in the problem. So for this fraction here, 3/1/4, you have to choose your goal. If your goal is to get a denominator of 20, just because that's what makes sense for the problem, then you do that by just multiplying by 1. It's just that you're disguising the number 1 as 5/1/5. Again, saying this as 5/1/5 helps students understand that it is just the number 1 and you are allowed to multiply anything by 1. If students understand the steps but are not convinced that this procedure is allowed, just plug the fractions into a calculator to get their decimal value. The fraction you start with and the fraction you end with have the same exact value, even though they look different. That's what it means to be equivalent. A good comparison for students is them just waking up in the morning and deciding what clothes to wear or how to style their hair. They may look different on the outside than they did the day before, but inside, the person who they really are is the same. Okay, on to adding and subtracting fractions. For adding and subtracting fractions, students need to fully understand two concepts. The first is what I explained before, that the denominator is the unit of measure, and the second is that you can only add or subtract numbers that have the same units. An example of this is 6 inches plus 1 foot. You cannot combine these two together to get one single number answer of 7 anything. It just does not work. You can only combine them into one single number answer after you convert one into the other. I think this example is really easy for students to understand, so if you continue to convey to students that the denominator of a fraction is its unit of measure, then the need for common denominators when adding or subtracting fractions should be easier for them to understand. Looking at 1/2, 1/1/2 plus 3/1/4, they do not have the same unit of measure. To get the same unit of measure, we need to convert one of them or maybe both of them. On the last slide, I said that the strategy you take should be based on all of the fractions in the problem. Because the denominator of 1/1/2 is easily converted into the denominator of 3/1/4 by multiplying it by 2, I would choose just to scale up the fraction 1/1/2. But please try and remember not to tell students that they are multiplying the entire fraction by 2, because they are not. That's wrong. They are multiplying the entire fraction by 1. It's just that the number 1 is disguised as 2/1/2 or 2 divided by 2. This example of 4/1/5 minus 2/1/3 would be like taking 6 inches and 1 foot and converting each of those into yards before combining. You are using a third completely different unit of measure, and you have to do that in this case because 5 is not easily converted into 3 by multiplying by a whole number and vice versa. So in this case, finding the least common multiple of 3 and 5 gives you the least common denominator, which is your new unit of measure and completely different than the one that you started with. Then your goal is to multiply each fraction by the number 1 disguised as something helpful that will help you get to that new denominator. The denominator of your result is always the same as the common denominator. That's because if you add centimeters and centimeters, your answer comes out in centimeters, not in kilometers or some other unit. Multiplying fractions. For multiplying fractions, students must understand that a common unit of measure is not necessary. And the reason is because with adding and subtracting, you are taking multiple quantities and combining them together. So they have to match each other. But with multiplying and dividing, though, you are taking just one quantity and scaling it. Showing your students simple examples like this can help them to understand. 4 times 3 feet just means 4 of 3 feet. Or in this example, half of 3 feet. You can get a single number answer right away without having to somehow convert 4 and 1/1/2 into feet first. Also, when multiplying fractions, you multiply straight across. The actual mathematical reason for this is pretty difficult to explain to students, so instead I would just show them a couple of examples that are easy enough to draw out and reason in their head. For instance, 1/1/2 times 1/1/4. That just means half of 1/4. So take 4/4 of a pizza and cut them all in half. Then you take one of those halves and then ask yourself, how does that compare to the entire pizza? Well, it's 1 out of 8 slices, so 1/8 of a pizza. Similarly, for 2/1/3 times 1/1/4, take your fourths and divide each of those into thirds. Then take 2 of those thirds and then compare that to the entire pizza. You have 2 out of 12 total slices. With these 2 examples, you can show students that how when they multiply fractions, the numerators get multiplied together and the denominators get multiplied together. But you can do it without a difficult mathematical proof and just by reasoning through it. One final note on fractions is that you sometimes need to write a whole number as a fraction, like this, 5, here. The good news is that you aren't just randomly giving it a denominator of 1. The 1 is always there. We just don't write it because most of the time it isn't necessary. If you were to say the number 5 using fraction language, you would say that there are 5 wholes. And that helps students understand that the unit of measure or the denominator is just one whole. Okay, to summarize up, doing lots of repetition with fractions is obviously important to help students remember the skills. But equally important is using the right vocabulary and using good examples to show students how things work the way that they do. The best way to help your student be successful in math, not just now, but in the future, is to help them understand the reason behind the processes. To do this, as you're working with students, try to connect each problem back to one or more of the fundamental understandings listed here. Here are some links that I like that provide step-by-step guides for different operations with fractions. I hope I was able to provide you with some examples or explanations to bring to your tutoring sessions to help your student understand fractions beyond the rote processes. Goodbye.